Hello students, welcome to my class. In this class, I will tell you about the concept of limit. Before telling you what limit is, I will tell you why we should use limit. We use limit to find the instantaneous rate of change of function with respect to its independent variable, or sometimes we want to know the behavior of a function nearby some particular point where the value of the function is indeterminate. So let me show you with an example. Suppose a particle is moving in a straight line along positive x direction. Here O is the origin from where the particle is started its motion, and at any time instant t, the position of a particle, say x, and we can write x as a function of t. Now if I know x as a function of t, then we can easily evaluate, or we can easily find the value of the position of a particle at any time instant. Say for time instant t1, the position of a particle is x1 equal to f of t1. Time instant t2, the position of a particle x2 equal to f of t2. Here I choose t2 greater than t1. Now I want to know how fast our particle is moving. That means I want to know the change in position of a particle with respect to the change in time. So we have defined a formula that is known as average speed, or I can say average rate of change of the position of a particle with respect to the change in time. So I will write x2 minus x1 by t2 minus t1. Now if somebody asks you what is the speed of the particle exactly at time instant t1 or exactly at time instant t2, then we cannot use this average speed formula. So how to find it? For this we have to know the concept of limit, and after we learn how to calculate limit, then I will show you how to find the instant speed, or we can say instant rate of change of displacement with respect to time. The same concept of average rate of change of displacement with respect to time we can define for any function, say y equal to f of x. So we evaluate the value of the function f of x at two different value of independent variable, which I will take here x1 and x2. So from the function it is very easy to find the value of y. So at x1 the value of the function, say y1, equal to, we can write f of x1, and at x2 we can write y2 equal to f of x2. Now what is the average rate of change of function f of x with respect to x? We can write average rate of change of function f of x, we can write y2 minus y1 by x2 minus x1, that is f of x2 minus f of x1 by x2 minus x1. And if we want to calculate the instant rate of change of function f of x with respect to x, then we have to learn a lot about limit, and then we can tell how to find the instant rate of change. Now let me choose another example to show you how to find the behavior of a function nearby particular point where the function value is indeterminate. So here I choose y equal to f of x equal to one function x square minus 1 by x minus 1. And if I want to evaluate this function, say x equal to 1, then what will be the value of the function? We will write f of 1 equal to 1 square minus 1 by 1 minus 1, and we will see the function value will be 0 by 0. Now 0 by 0 is not a number because we cannot divide any number by 0. 0 itself is a number, but we cannot divide by 0. So this type of value we say indeterminate values. Now, but we want to check the behavior of this function, or I can say how my function behaves if I choose the value of x very close to 1. Now in how many ways I can choose the value which is very close to 1? So let me show you. We generally plot any graph in a Cartesian plane where along the x-axis we plot the independent variables, and along the y-axis we plot the value of dependent variable. So on the x-axis, if I choose this value x equal to 1, now I want to choose the value of x which is very close to 1. Now there are two ways. I can choose the value of x which is greater than 1, that is from right side, from this side, and which is very close to 1. Say I can choose values like 1.1, 1.01 or 1.001 or 1.00001, or in this way you will go on. Another thing, we can choose the value of x also from the left side of 1, that is the value of x which is lesser than 1 but still it is very closer to 1, but it is from the left side. Say we can choose 0.9, then 0.99, then 0.9999, and so on. So these are the values from the right side of 1. These are the values from the left side of the 1. Now let us see, if we evaluate the function on these values, then what will be the output of the function? Let us calculate. So I make a table here x, and here I will write function x square minus 1 by x minus 1, and on the top I am putting the left side values of 1, that is 0.9, 0.99, 0.999, and the arrow represent we are moving closer to 1, and from the right I will choose 1.1, 1.01, 1.001, and the arrow direction will show you that you are moving from right towards 1, and say somewhere here the value x equal to 1 lies. But we will not evaluate the function at x equal to 1, as we have already seen the value of the function at x equal to 1 is indeterminate. But we will evaluate the value of the function at all these points which I have mentioned in the table. So at x equal to 0.9, what is the value of the function? We will write 0.9 square minus 1 by 0.9 minus 1. So by using simple algebra techniques, we can write the answer is 1.9. For the next value, the answer is For the next value, the answer is 1.99, and for the value of x, which is 0.999, then the value of the function will be 1.99. And similarly, we will calculate the value of the function at x equal to 1.1. We will get the output as 2.1. Here we will get 2.01. Here we will get 2.00. Now, from this table, if I look at the output, what we can infer? We can see that my output is moving closer to some particular number, that is, we can say 2. You can see here, first at x equal to 0.9, my function value is 1.9, and then when I move closer to 1 from the left side, my function value is moving closer to 2, and from the left side of the 2. Or if I move x very close to 1 from the right side, the output of my function is moving also closer to 2. So we can say that my function output value is approaching a limiting value, that is 2. So we can write, or we can say, the limit or the approaching value of the function is 2 when x is approaching to 1. Now this whole concept we can write symbolically as limit x tends to 1, x square minus 1 by x minus 1 equal to 2. So we can now extend this definition to any function, or we can write in more general sense, the limit x tends to c f of x equal to L. That means f of x is a function which is defined in an open interval containing c, and it is not necessary that f of x should be defined at the point c. Then when x is approaching towards c, if the output value of the function f of x is approaching towards L, then we can say the limiting value of the function is L when x tends to c. That is all about the concept of limit. In the next lecture, I will tell you how to calculate limit using the properties of limit, and we will learn a lot about limit, and I will also tell you after studying limit, that how to use this all properties of limit and the limit idea to calculate the instantaneous rate of change of function with respect to its independent variable. That's all. Thanks for watching. Thank you.